All right, good day, everyone. What we're gonna be dealing with today is dealing with basically graphing rational function, going through a process, being able to find different things and actually apply it so that we can actually get a graph of a rational function. Okay. One of the things I want you to understand is that within this lesson, what we're gonna be doing is finding a lot of different pieces of the material. So the thing I really want you to focus on, not necessarily like actually graphing it, it's more the thing I want you to focus on is actually how do we find these pieces? Okay. With the setting being remote learning, I don't really care about the graphs itself. Okay. Any one of you could plug it in the graphing calculator, Desmos, or things like that. The key thing that we are going to want you to find and look for is actually how to gather these pieces of information. So if you notice in this section, at the very least, at the very start, if you look at this little piece of information right here, they literally go through everything you need to graph a rational function. Now, finding the intercepts, the horizontal asymptote, the vertical asymptote, basically those first three are going to be key for us. Okay. After that, when it comes to end behavior and even the calculator window, it really doesn't matter to us because we can graph these out at any point. So notice a lot of things I'm going to focus on today is just going to be how do I find these specific values? Okay. Now, one of the things I want you to look at is just in this first example. Basically, notice how they go through and they find so many different things. Okay. They plot and find the intercepts. Then they go through and they talk about the vertical asymptotes down at this point. Then they talk about how that vertical asymptote can be affected, basically to find the end behaviors, which we can talk about easier ways to do that. But they go through this process of basically finding everything. Okay. Well, what I've done is I've kind of broken down into four main things that we're actually going to find within class. Okay. The x and y intercepts, the vertical asymptote, and the horizontal asymptote. Okay. And within class, we're going to talk about these extensively, all right? How to find each one, how to actually work through it. And I'm actually going to go through an example here and talk about how to actually find each one. But these are kind of just a basic idea of each value, okay? For the x-intercept, we're going to solve for the top. The y-intercept, we're going to plug a 0 in for x. Okay, those have been kind of universal for us. Vertical asymptote, it's basically our restrictions on the bottom. And then the horizontal asymptote, kind of a different idea, but we're going to teach it basically there's three different possibilities. Okay, and a horizontal asymptote, we're basically going to look at the degrees of our function. If the bottom degree is larger, our answer is 0. If they have the same degree, we have a ratio. And if it has the top degree, we have the oblique. Okay, now we're going to talk about a lot of the horizontal asymptote in class because it is one of the more complex things that we're going to just discuss. But within today's video, we're going to focus on one of the problems, which is a 0 horizontal ratio or horizontal asymptote. So we can talk about kind of how we come up with that, okay? And then within class, when we can ask questions, we'll talk about the same and then the top and oblique ones and things like that, okay? But let's go ahead and get into it. So graphing rational function. Basically, if I'm given letter A here, okay, we can just cross out letter B. We won't even worry about this one. But if I'm given letter A here, okay, I want to be able to graph this out. So let's go through the process. Step one, let's find our x-intercepts, okay? For the x-intercepts, I only care about the top portion of this function. Okay, so what that means is all I have to do to find the x-intercepts is take the top of this fraction, which is just x, and set it equal to 0. Okay, now sometimes you'll get like the example from letter B, which is like x squared minus 5, and you actually have to solve things out. In this case, because the top of that function is just x, I set it equal to 0, and I'm done there. Okay, so notice that we already have our x-intercept. We can go ahead and plot that. We have an x-intercept at 0. Sometimes you won't even have an x-intercept. Sometimes you do. Kind of just depends on the problem. Next, we go to our y-intercept. Another easy one. We just plug 0 in for x. So if I plug 0 in for x, this would be 0 over 0 squared minus 2 times 0 minus 15. At that point, if I work this out, I would have 0 over negative 15, which is going to come out to be 0 as well. So I actually also have a y-intercept at that coordinate right there. Okay. Continuing on, find the rest of them. Our vertical asymptote. This is where we have to do a little bit more work. At the bottom, we have to set it equal to 0. So we have x squared minus 2x minus 15. If you notice, if I set this equal to 0, we have a factoring problem. So I'm going to do x method, negative 15 on top, negative 2 on bottom. This would come out to be negative 5 and then positive 3. Excuse me, I wrote a 2. I can probably fix that. Positive 3. Multiplied, give me negative 15. Added, give me negative 2. And then from there, I get to my value, x minus 5, x plus 3. And if I simplify those, I get the two answers. X is 5, and -3. So I get the two vertical asymptotes at 5 and -3. I can go to my graph over here at 5. I can draw my asymptote. And at -3, I can draw my asymptote. Okay? Notice how everything so far has just been using math we've done in the past. It's just trying to understand how I'm going to apply it. For example, the x-intercept and even the vertical asymptote are kind of the same thing. I set a value equal to 0 and I solve. Now, the x-intercept was just 0 because there's only an x on top. The bottom value, that x squared minus 2x minus 15, now that we have a quadratic function, we're going to have to take a little bit more time, work it out, and actually get to our final answer. Okay, so see what I'm trying to say? The reason we're flying through this is because it's information we've talked about in the past. Is just how do we actually apply it? Okay. Now the different one might be your horizontal asymptote. Okay, and this is going to always go by a check. Well, if I look at this equation, technically we want to look at the degrees of the function. Technically, you have a degree 1 polynomial on top, so it goes degree 1 over a degree 2 on bottom. Okay, and that's kind of the key thing we want to focus at. Notice how the exponents of each of those, the top one is a 1, the bottom one is a 2. Well, whenever we do horizontal asymptotes, there's basically a rule check. We want to check those 2 degrees and then go back to these 3 possible rules. Well, since the bottom is larger than the top, our answer automatically is going to be 0 as a horizontal asymptote. Okay? Now, like I talked about, we'll have 2 days to go through this lesson, and in class, we'll talk about these a lot more and how they're going to affect it. But that's kind of the idea of it, and that's basically the math behind all of it. If I'm going to check for a horizontal asymptote, all I have to do is check the degree of top and bottom and then follow my rules after that. So in this case, because the degree is larger on bottom, we have a 0 for that value. Okay. Now, here's where we're at right now. We have our 2 vertical asymptotes and our 1 horizontal asymptote. We have our coordinate, and then we can actually start to graph. Now, one of the common questions that always comes up is, how do we have a coordinate through our horizontal asymptote? Okay. One of the things I want you to understand is that a horizontal asymptote isn't a restriction line. Okay. Really what the horizontal asymptote does is it describes your end behavior. So for example, I can cross a horizontal asymptote. I can actually go through it. I can have a coordinate that's going to equal it. However, when it comes to the actual lines that I draw at the end of this, it will always have an ending value. Okay. Okay, the horizontal asymptote really represents what value I'll never reach by the end of this graph, but I can still intercept it or intersect it at some point during the function. Now, the vertical asymptotes are exact restriction lines. You cannot cross those whatsoever. Okay, those values are set in stone by our math that we cannot actually assess them or actually cross them. The horizontal asymptote is more of a descriptive piece for end behavior. Okay. Now, here's the thing, and this is why I'm not really going to take too much like points or anything like that for the graphing portion. At this point, you would plug this value in the calculator, or you would test coordinates, or you'd work through it like that. Okay, you would actually test the values within a calculator and actually try to get your final answer. Well, really, I don't need you to do that. Okay, within the class with remote learning, we have the ability to do all that. So really, what you would do then is just plug this equation into Desmos, and you would sketch out your graph. This graph is going to come out to look like this. Okay, your middle line looks like so. You have one in the bottom left and one in the top right. Okay, notice how the asymptotes are actually guiding your lines. Okay, they're actually guiding where the value is going to go and help you out. Okay, that's kind of the next thing I want you to understand is that your asymptotes, and what we kind of talked about with transformations, your asymptotes kind of guide your thinking and guide your graph. Okay, but this is kind of the process that we're going to be talking about over the next couple of days. How do we take a function like this and get all these different pieces of information? Now, in class, we're going to go more in depth. We're going to talk about what happens when we have vertical asymptotes, what happens when we have more complex horizontal asymptotes, how do we cancel, how do we simplify, all those different things. But for this video, just because I don't want to make it too long, we're going to just go through the basics and then cover the rest of it in class. Okay? But besides that, thank you for watching. I'll see you in class tomorrow, and have a great day.